Welcome to Triangle Trigonometry Test Review. Let's go ahead and start question one. Find the exact value of the six trigonometric functions of angle theta in the right angle below. So the angle I'm going to be focusing on is going to be this particular angle here. Now to answer the six trigonometric functions, we're going to be looking for sine, cosine, tangent. Actually, let's go ahead and write theta on each one. Because what we're going to do is we're going to look for this angle, but we're going to look at specifically those three, and then also cosecant theta, secant theta, and cotangent theta. And here's the six trigonometric functions. Now, one of the things we got to remember is this word, which you all have memorized, Sohcahtoa. Now, the reason why Sohcahtoa is so important is because this gives us a quick acronym to define opposite over hypotenuse, or basically to get the exact value of what these angles are going to be. Now, one of the things that we need to do, though, is that right now I have leg and leg. I have A and B. However, I'm missing C. So the nice thing about that is I can find out what it is by applying a quick Pythagorean theorem. Remember, Pythagorean theorem can only be done because in this case we have a right angle. You need the right angle in order to apply Pythagorean theorem. Otherwise, do not attempt to apply Pythagorean theorem. It will result in an error. So here we go. 5 squared plus 3 squared is equal to c squared. So we'll get 25 plus 9 is equal to c squared, which means that in this case we'll have 34 is equal to c squared. Let's take the square root of 34. And pretty much the only thing we have to maybe think about is that if the square root of 34 could be reduced. And I believe it cannot, because when I think about all the numbers that we might be able to do, like 4 or 8 or let's see, anything else, 16 at the highest, no, it just won't work. So we'll have the square root of 34 as being our hypotenuse, or C value. Now, let's go ahead and actually define this. Now from here, okay, this side over there, so basically this right here, and I'll take it off, this is my opposite side. This is my adjacent side because it's next to it, and this is my hypotenuse. Now I'm going to go ahead and take all that off because it makes it quite messy, but I wanted to go ahead and point that out to you so when you see this, you'll know exactly what I'm going for. Like when I do Sohcahtoa, the Sohcahtoa part, okay, it's opposite of our hypotenuse, so that means I'll get 5 over the square root of 34. Remember, we can't leave the square root of 34. We need to rationalize it. So this one is going to be 5 times the square root of 34 divided by the square root of 34. That's your answer for that one. Cosine. It would be adjacent over hypotenuse. So 3 over the square root of 34. Same thing. Rationalize the denominator. So when I rationalize the denominator, I'll get 3 over the square root of 34 over 34. There's my answer for that. Now adjacent, that's just going to be opposite, which is 5 over adjacent, which is 3. So that'll be your answer there. Now let's go ahead and move on to these over here. Now remember, the cosecants are just the inverse of the other ones. So in this case, instead of having opposite over hypotenuse, we're going to have hypotenuse over opposite, which means like this, h over o. This is the inverse. Now in this case, we have the square root of 34 over 5. That one does not need to be rationalized. The next one's going to be hypotenuse over adjacent, square root of 34 over 3, and cotangent is going to be 3 over 5, which is opposite over, not opposite over adjacent, adjacent over opposite. That's all it's going to be. Okay, fantastic. There's your answer for number 1. Let's go ahead and move on to question 2. Now it says right here, find the exact value of the following expression using the complementary angle theorem. Show your cone function replacement to get credit. Now, what it's saying is that we have something, when we have right angles, we have cofunctions, and this is saying that already belongs to complementary angle theorem. Now, what are cofunctions? The sine of theta, or actually the sine of alpha, is equal to the cosine of beta, which means that complementary angles, being these in this case, alpha and beta, because of this being a right angle, alpha and beta automatically add up to 90 degrees. So the same must hold true here. And let me give you an example of what I'm talking about. If I was going to replace this with cosine of 58 degrees, this is a sine of 32 degrees. Why? Because 58 plus 32 equals 90 degrees. So this is what the complementary angle theorem is. It's what they want you to show in order for you to be able to get credit for this. Now, what I'm going to do is I'm going to do this the fastest, most efficient way. I'm going to go ahead and replace this one. If I make this into sine of 32 degrees, I could go ahead and just convert this whole thing to say, okay, this is really the tangent of 32 degrees. The reason why I want that is because, oops, the tangent of 32 degrees minus the tangent of 32 degrees is 0. Your goal is to go ahead and try to get these equal to each other. And what I mean is that you try to get them in a common form, and we could either go ahead and reduce them. Now, is this the only way to do it? No. Why? Because you could manipulate these equations to look in different ways. This is the easiest way to do it. But you could certainly get a different answer. You get the same answer, not a different answer. You go ahead and get the same answer, 0, but applying a different technique to do these trig functions. Now let's go ahead and move on to question 3, geometry. The hypotenuse of a right triangle is 12 feet. If one leg is 8 feet, find the degree measure of each angle. Okay, great. Now, if anything, if it says one leg and doesn't specify the leg, that means you get the liberty to go ahead and say which one you want it on. And it really doesn't matter because all the angles will be, you will arrive all at the same angle measurements. Just maybe the locations might be slightly different, but there's only really one. I'm going to call this 8 feet. What do they want? They want alpha, they want beta. Find the degree measure of each angle. So they just want alpha and beta. Now, how can we go ahead and do that? Okay, if I go ahead and start with this angle here, okay, I have adjacent over hypotenuse. So like cosine of alpha is equal to adjacent over hypotenuse, which in this case it's 8 feet over 12 feet. I'll put 12 feet here. Now, what must I do after this? Well, you can reduce it if you want. This is really, let's see, 4, 2 over 3, 2/3 feet on each side. But the most important thing we got to do, though, is we need to take the inverse. Cosine inverse, cosine inverse. And let me bring up my calculator. And then I'll make it slightly better here. Oops. Hold on. Okay, there we go. All right, now what is going to happen? These are going to cancel out. You'll be left with alpha cosine inverse of 2/3. Now, when we deal with these, since they want the thing in degrees, you got to make sure your calculator's in degrees. When you do this test, make sure to go to mode first and make sure that it's marked off in degrees. The reason being is if I'm the type of person that resets my calculator, okay, I may go back to mode, and you notice how it's in radians. What you need to do is go there and make it into degrees. So in this case, I need to make sure it's in degrees. Otherwise, you'll get some unusual answers. And if that's the case, if you do get unusual answers, please check that. Remember to check that. Ooh, hold on. I forgot the 3 there. So let's try it again. Cosine 2 divided by 3. There you go, 48. So that means in this case, alpha is 48.1 or 48.2. Alpha is 48.2 degrees. So if that's 48.2, that means that beta is going to be 90 minus that amount. The reason being is because, remember, we know that they're complementary angles. So 1 minus 48.2 results in 41.8. And there you go. You have your 2 angles, and you are done with this. Now let's go ahead and move on to the next question. It says right here, find B, C, and beta when the information is shown, or it says use a right triangle shown and information provided to solve the right triangle. Okay, fantastic. Let's go ahead and get started with this. Now remember, this is a right angle. Alpha, beta. We're given that A is 4 and that alpha is 37 degrees. Okay, fantastic. Now, we know that that's 37 degrees. I could easily find my first answer, beta, by just applying complementary angle theorem, which means in this case, it's 37, so I'll take 90 minus 37 and find out that beta is 53. So let's go ahead and write in here 53 degrees. So here you go, 53 degrees. Now, let's go ahead and find out the rest of these. Now, for that, we're going to use Sohcahtoa. And um, I'm going to go ahead and use this angle in particular. This is an angle I'm going to use. And I'm going to use it with the tangent. I'm going to go ahead and do, because see, the thing is that this is opposite over adjacent in this side. So I'm going to take the tangent of 37 degrees and use it over b over 4. Now, the reason I'm doing that is because this is the simplest way to solve it. Now, there's alternate ways. Don't think that this is the only one, but this one is the easiest as far as that this requires just one step in algebraic manipulation to make it happen. You could use other trig functions. You could have used this angle here and done tangent as well, but you would have to do maybe more than one step to get the math solving right. Now let's go ahead and solve what this is. This is okay. This is 4 times tangent of 37 degrees, which comes out being 3.01. So that means that this side is 3.01. So B, 3.01. Now from here, you can use Pythagorean theorem or you can use another trig function. Now I'll use another trig function because I want to point something out to you. I'm going to use the same one, the 37 degrees, but I'm going to use it in this case. Put it over here, but I want to use it in the sense that if I use cosine, now cosine is adjacent over hypotenuse. So what's going to happen in this case? 37 degrees, I'm going to get adjacent over hypotenuse, which is C. So I need to solve for C now. The only thing is that C is in the denominator in this case. Now, one of the things what you're going to need to do is, this is really a proportion. So you could think about this if you run into this situation, kind of like cross multiply and divide. Because what needs to be done is the C needs to multiply on this side, and the cosine 37 degrees needs to be divided over there. That's how you get the cross multiply divide. And we do that quite frequently with the law of sines as well, because that's something that will also show up there. Now, only thing that needs to be done in this case is 4 divided by cosine of 37 degrees. Let me clear this. 4 divided by cosine of 37 degrees is going to achieve an answer of, 4 divided by the cosine of 37 degrees is going to give us an answer of 5. So 5.01. So in this case, C is 5.01. And the answer is reasonable. The reason being is, remember, hypotenuse needs to be the largest side. So C is 5.01. So here you go. This is the answer for question number 4. Now let's move on to question number 5. Find the grade of a mountain trail. It says a straight trail with a uniform inclination leads from a lake in a valley elevation of 4,100 feet to a hotel elevation of 5,000 feet. The length of the trail is 3,500 feet. What is the inclination grade of the trail? So what they're telling us, 2 things. First of all, remember, unless you're at the sea level, you're at 0. Like here in San Antonio, we're about 1,000 feet above sea level. They're saying that this hotel is actually at 4,100. All right, so here's sea level. All right, and a hotel is really at 4,100 feet from sea level. The hotel right here. And they said that you climb, and you never climb straight up, you always climb in an incline. But the hotel is at 5,000 feet. I'm sorry. So I was saying the valley is at 4,100 square feet. So let me rephrase that. Yes, I did say hotel, but the hotel is actually here where they're trying to achieve. So this is 5,000 feet. Now what happens is the right angles form from that trail to there. And we know that this trail is 3,500 square feet. The question being is this: what is this inclination angle that is there? Now, if this is 4,100 feet, that means that in this case, this answer, this amount here is really 900 feet. And that's going to be important to know because now I could go ahead and use trig function using this to go ahead and identify that I have opposite over hypotenuse. So it would make sense to use sine of alpha to figure this answer out. So I'm going to go ahead and do that. Sine of alpha is going to be 900 feet over 3,500 feet. And the only thing we have to do is take the inverse and the inverse over here. So alpha is really equal to then the sine inverse of 900 over 3,500 feet. So let's go ahead and find out what that is as a calculation and find out our angle. Sine inverse 900 divided by 3,500 means that we have an inclination angle of 14.9. So 14.9 degrees is going to be our inclination angle. And that is our answer. That's what this is, inclination angle is. And that seems about reasonable. Remember, when we climb up things, even that long, you know, it's still, you can't have too high of an inclination angle because otherwise it'll be really difficult to climb. Now, let's go ahead now. The biggest thing that I wanted to maybe share with you is that this is talking about inclination. Sometime when they're talking about, this is like an elevation angle. It's elevation. When sometimes they go ahead and talk about a de-elevation angle. The de-elevation angle, remember, elevation angles are measured like this. This is elevation. De-elevation is like this. I just want to make sure you understand that. So if you encounter that, you know what are we talking about as far as how to form the triangle. Now let's go ahead and move on to the next question. Now it says right here, solve the triangle by finding the remaining sides of the angle using the law of sines. And the law of cosines is appropriate. Find the area of each triangle that is a solution. Some problems may have more than one triangle. So right here, this is already starting to lead us to believe that we're going to have to check each of these to see if they have more than one solution. So, and if they do, we're going to have to go ahead and apply both. So let me go ahead and remember, you have a formula chart that you can use. It's in the pink sheet that has all these formulas in it. Now let's go ahead and first remember, before you start any of these problems, always start by drawing the triangle. And what you want to do is draw the triangle such a sense you don't really put anything in yet. At least you know what's going on with the triangle. And you can start with capital A, lowercase a, directly opposite from it. This is alpha. Capital B, lowercase b, opposite from it. That's beta. Uppercase C, lowercase c, gamma, directly from it. And then let's go ahead and fill in the actual things that we do know. Like we know that gamma is 40 degrees. Let's see, we know that C is 2. And we know that alpha is 10 degrees. Now this is why it's important to list everything, because when I use the law of sines, the first thing I'm going to look for is this. And the reason being is because one of the law of sines deals with sine of alpha. Well, actually, the thing that I do know, sine gamma, which is C, is going to be equal to sine alpha over A. And I know 3 of the sides. You need to know 3 of the unknowns to solve for the last one. So like in this case, I'm going to go ahead and find the sine of 40 degrees. It's going to be over 2. It's going to be equal to the sine of 10 degrees over the unknown A. Now remember, when we do this, we cross multiply and divide. So what I'm going to do first of all is I'm going to go ahead and cross multiply it, and then we're going to go ahead and divide what we're going to do. So like in essence, remember when we cross multiply, and then we're going to divide by this. So we're going to do 2 times sine of 10 degrees divided by sine of 40 degrees. That's what it means when you cross multiply and divide. So like in this case, let's go ahead and do that whole procedure right there. Let's see. Let's bring out a calculator, and let's do this lovely formula here. So now I'm going to clear it so it can look nice. 2 times sine of 10 degrees. And we're putting it separate because I always like to, and then divided by the sine of 40 degrees. I like to do that in order to achieve. Now, it's saying that the answer is, in this case, 0.54. Now, that is quite small, which makes me believe that there might be an error into it. Let's find out now. Well, possibility, I mean, that is 2, and that is 10 degrees. So I would say that that actually may be right. The only thing I'm going to check is this little tad bit thing that I did there, which is 2. I just put 2 sine 10. I'd rather actually multiply that out. I actually put a little multiplication symbol to make sure I did not make an error. Remember, check for the reasonableness of your answer. And the only reason, ooh, hold on a second. Get a better angle at this. Okay, so 2 times sine of 10 degrees. Now remember, 10 degrees is a pretty small angle, so actually that answer might be right. I think it is. And the only reason why is because 10 degrees is really tiny. Yeah, that is it. 0.54. I'll put 0.540, 0.5403. 0.5403. So 0.5403 is the angle for A. Now, if this is true, if this is 40 degrees and this is 10 degrees, that means that in this case, I have an actual angle of over here. This is going to be 180 minus 50, which is 130 degrees. That's a possibility, is what it's saying. Now, let's go ahead and actually start. Now I got 0.54. Let's go ahead and use that for beta. And we know that's 130, and I know that's what it is. Let's go ahead and do the same thing we did before, and where we're going to take sine of 40 degrees. Let me make sure I did the setup right. Yeah, sine of 40 degrees is equal to 2 equal to the sine of 130 degrees over b. Now again, cross multiply and divide. So cross multiply, divide. So 2 times sine of 130 degrees over sine of 40 degrees is equal to b. So let's go ahead and actually redo that again. And 2 times sine of 130 degrees divided by, well, let me do that first, and then divided by the sine of 40 degrees. 2.3835. So that'll be the answer, 2.3835. So I'll go ahead and round that, 2.3836. 2.3836. 2.3836. So there's the answer. Now you have all the answers for this. The only thing you have to maybe check for is to see if there's a second solution. And the reason why you want to do that is that, and also, so we went ahead and found all the sides of the triangle. So if you want to, after you're done with this, and you can go ahead and write in the missing information. Not C, but A was 0.5403. Beta was 130. And the last one is B in this case. Now, we're not going to look for a second triangle on this one. And the reason being is that I think that's only in a special case when you're given sine, angle, side. Since we're given angle, angle, side, that's not the case. Remember, this is an angle, angle, side triangle. The only time we have to look for a second triangle is when you have side, side, angle. So there's no necessity to check yet for this one. Let me go ahead and write down the other one. B is 2.3836. Now, one of the things I could do, though, is I could find the area of each triangle. So I could go ahead and find the area. So this is the answer to I of number 6. Let's go ahead and actually now do the area of this triangle. Now, the area formula you could use is really any of them, because in this case, the area formula you can use, I'm just going to use the first one that's listed in the pink sheet, which is area is 1/2 A times B, and this is the area formula. So let me go ahead and just make a little division marker here. A times B sine alpha. So let's go ahead and fill in the missing information. 0.5403. B, which is 2.3836, 3836 times sine of 10 degrees. So there we go. So we just need to input that all into our calculator the way it's shown, and we'll get the area formula. Ooh, and it does that to me. Get that a little bit better. Wants to do the same thing. Does it? Okay. I'm gonna go ahead and just kind of keep on. Technology sometimes. So there it goes again. All right. Now what I'm just gonna do is just go ahead and just type it out. 1/2 times AB. So first of all, I'm gonna clear this. 1 divided by 2 times that 0.50403 times the other one, which was 2.3836. Yeah, 3836. 2.3836 times the sine of 10 degrees. So here the area of this is 0.11, and I'm just going to say 0.11 units squared. That's all I'm going to put it at, 0.11 units squared. So let's go ahead and put that down, 0.11 units squared. Now let me just double check this real quick because I wanted to make sure that we have, oh no, you know what, this answer seemed pretty small, so I wanted to make sure that it seemed unreasonable. So I went ahead and checked my formula, and it is. The reason being is that for formula, I went ahead when I looked down on it. This is really gamma, which means that, and the reason being is that when I looked down on it, I think the gamma and alpha look somewhat similar, just one is slightly the reverse. That means that this one is really going to be 40 degrees. So when I go back to my calculator, the only thing that needs to be changed, I'm going to bring up the original one, is this last part right there. Let's make that into 40 degrees. And this time I get 0.4139. Still tiny, but more reasonable. And that might be true because now we're dealing with units. So if you have a side that's already half times, it's probably pretty tiny in itself. But just let me make sure I do have this still right. A times B, sine of gamma. Oh, that's right. So that means in this case, I'm going to go ahead and take 0.543. Yeah, that's going to be the answer, 0.4139. 0.4139. So the answer is going to be 0.4139 units squared. I don't think they gave us any kind of unit measurement with this, so it's probably going to be units squared. All right. Now, let's go ahead and now look at the other parts of this, and let's see if it gives us anything else that we need to do here. Okay, now this is it. So problem 6 to 10. All right, so let's go ahead and move on to the next one and apply the same principles. Now remember, this one is side-side angle. Oops. So for this one, it may be necessary to go ahead and actually this one, we're going to have to check to see if there's a true triangle solution to this. But again, start by drawing the triangle and labeling just parts. A, lowercase a, B, well, alpha, B, lowercase b, beta, C, lowercase c, gamma. And then from there, they fill in the stuff we know. 100 degrees. 1. Oops. This is really C. Well, actually, let me go ahead and just, instead of doing that, let's go ahead and just fill it in. C is 4. So in this case, we actually have side-side angle. Now from here, we can do a couple of things. You can still, let's see, we really can't use the law of sines. And the reason being is because the law of sines, remember, we're missing one of the angles here. So we can use the law of cosines, though. And the law of cosines is going to be used because we know we have alpha and we have B and C. So the law of cosines that will help us achieve an answer, knowing that we have B, C, and alpha, is going to be the law of cosines that says A squared is equal to B squared plus C squared minus 2bc cosine of alpha. So in this case, what do we do now? Well, let me change colors and let me go ahead and actually fill in 1 squared plus 4 squared minus 2 times 1 times 2 times 4 cosine of alpha, which is 100 degrees, is equal to a squared. So remember, a squared, this is equal to 1 plus 16 minus 2. This is going to be 2 times 1 times 4 is 8 cosine 100 degrees. Now, remember, do not forget your order of operations. You need to deal with PIMDOS first. So you're going to first do this part of it here, and then move on to subtracting them. I was noticing in a couple of people's problems when they've worked on this that sometimes they wouldn't do that. They will go ahead and actually not follow the order of PIMDOS, and that would result in errors. So let's go ahead and do that. 8 times cosine of 100 degrees, which comes out being this. Oh. Now, when you get answers like this, possibly degree, not necessarily. No. All right, so that is an actual answer. Now, on this side over here, that's going to be 17. So I'm going to do 17 minus this answer. Comes out being 18.38. So like in this case, a squared is going to be 18.38. Go ahead and do that. A squared is equal to 18.38. So from here, I'm going to take the square root. Square root. A is going to be equal to then, let's take the square root of the answer, 4.2883. 4.2883. 4.2883. Now, from here, let's go ahead and actually use that A, which we know. Now we need 4.2883, and use it to solve for one of the angles. Once you do this and you have one of the angles, you're actually able to now use the law of sines to solve for the rest. And I think a lot of people feel comfortable with the law of sines. Remember, you have sine of alpha. We have this 100 degrees is equal to the A, which is 4.2883. We have to go ahead and now see, why don't we figure out what gamma is? Sine of gamma over 4. So from that, I'm going to also do cross multiply divide. So I'll just have to cross multiply this, and I'll be left with sine gamma. And really all I'm doing is multiplying by 4, multiplying by 4. For those who remember proportions, it's easy just to think about cross multiplying that. So I'll find out that in this case, let me clear this, 4 times the sine of 100 degrees divided by 4.2883. Now, I'm going to take the only thing that we have left to do is take the sine inverse of that. And I'll show you why right now in a minute. I'll find out it's 66.7. 66.7. How to do this, of this whole thing. And the reason being is because these cancel, and you find out that alpha is 66.7. So that's what this, well, not alpha, gamma. All right, so we know that's 66.7. That one of the triangles that gets formed automatically, it's going to be, oh, did they want us? Yeah, they wanted us to find all the missing angles. I don't know if they wanted us all the information. Remaining sides. Okay, yeah, so they wanted the remaining sides. So now the only thing that the only one we remaining on this one, we got to do 2 things left. I'm going to subtract 100 and subtract 66.7, 13.3. Okay, so this angle right here is 13.3. This is a possible triangle. Now with this one, okay, we have all the sides off. The only thing that you have to do that's left with this one, 2 things. You have to figure out the area of the triangle, but you also have to check for a second gamma. Remember, we found out that this is 66.7, but since this is side-side angle, remember only occurs with side-side angle, we have to check for second triangle. Okay, so gamma second. Oh, actually, don't put it as a square. More of anything is confusion into that. When checking for the second triangle, when you put gamma, put it as a subscript. Second gamma. The second gamma may be, now what it could be the second gamma. Remember, this angle in the law of sines said the 66.7, right? There could be possibly another angle over here that gets formed. How do we find what the other angles in the quadrant? You do 180 minus 66.7 to see if there's a second triangle that might be able to be formed. So let's go ahead and find out what that may be. 180 minus 66.7, that'll mean 113.3. So 113.3. That could be a possible second gamma. Now, there is a problem though, because remember my existing angle is 100. That's already automatically wrong, because I cannot go over 180 degrees. Can't go over 180 degrees. So, which means there's only one solution for this triangle, which is this one. Okay, so I have, this gives me all my components for answer 1. The only thing I have to do now is do answer 2 and find the area of this triangle. So for answer 2, since I have all components, I'm going to use the same one, the same formula as before, 1/2 a times b times sine of gamma, which in this case is going to be 1/2 a, which is listed as 4.2883 times b, which is listed as 1 times gamma, which is listed as 66.7. So let's go ahead and find out what all that is. I'll go ahead and move this just a little bit. There we go. All right, so let's go ahead and actually now do this. 1 divided by 2, 4.2883. I'll put a 1 in there. Multiplied by sine of 66.7. What does that mean? 1.969. 1.969. So area of that is 1.969, and there you go. Here's your area formula for part 2. So that's your answer. Okay, great. Now let's see. Okay, so let's move on to the next question. Question 8. Now this one is a side triangle. Just by looking, but again, just draw a triangle. Label ports. A, lowercase a, alpha, uppercase b, lowercase b, beta, uppercase c, lowercase c, gamma, and we know all these parts. 3, 2, 2. Now, when you have side, you can actually use any of the following law of cosines formulas to find out whatever angle you're looking for. Now, I'm going to go ahead and start with the cosine of alpha. So, like in this case, cosine of alpha, is going to be b squared plus c squared minus a squared divided by 2 times b and c. So in this case, let's go ahead and do that. Cosine of alpha is going to be then 2 squared plus 2 squared minus 3 squared divided by 2 times b, which is going to be 2 times c, which is 2. Yes, b and c are 2, so I have a lot of 2's in here. So cosine alpha is going to be then 4 plus 4 minus 9 all over 8. And I know some of you are going to be saying, understandable, hold on. You're going to get right here a negative 1 over an 8. That's okay. Reason being is that, if you remember, Cosines could be negative. It's probably going to be a larger angle. So let's go ahead and find out what that is, though. Second cosine of negative 1/8. Negative 1 divided by 8. Ends up being 97 degrees. So in this case, alpha is 97 degrees. What did I do at the end? Took the inverse. So the very last step. And I found out that this was 97, I think it's 97.1. Let me double check that. Yes, it is. 97, actually 97.2. To be more accurate. So let me go ahead and write that down. This is 97.2 degrees. Okay, now let's go ahead and now deal with the other ones. And really only have to find one more. Let me go ahead and use find out the one for beta. So let's go ahead and do that one. Cosine beta is going to be a squared plus c squared minus b squared over 2ac. So when I do this one, I'm going to go ahead and do a, which is 3 squared, plus 2 squared minus 2 squared over 2 times 3 times 2. So that means that in solving this, this is 9 plus 4 minus 4 all over 2 times 3, which is 6, 12, which means we'll get 13 minus 4 over 12, which means that we actually get 9 over 12, which means that I have to take the cosine negative of this. And the reason being is because, remember, this is for cosine beta. So if I do this here, these cancel out and I figure out what beta is. So let's do that. Second cosines of 9 divided by 12, 41.4. So this one's going to be 41.4. So this is 41.4. And the last one is going to be found easily by doing 180 minus 97.1. So 180 minus 97.2 minus 41.1. Or 41.4. I'll get 41.4 as well. All right, so 41.4 is this one over here. It probably makes sense because they're isosceles. This is an isosceles triangle in a way. 41.4. So there you go. So you have your 3 angles there. Let's go ahead and move on to the next one. Okay, we have another side-side angle on this one. So this is going to be side-side angle. So this one, because of that, you check for a second triangle. Okay, so before going into all that, though, let's go ahead and first draw a triangle, like always. And drawing this triangle, we'll go ahead and actually end up with, I'll just put A, lowercase a, alpha, B, uppercase B, lowercase b, beta, uppercase C, lowercase c, gamma. And then it's actually fill in the sides. We have that this is 2. Actually, let me go ahead and oh, took out more information than I wanted. What I wanted to do is just change colors. That's 2. This is 1, and we have gamma, which is 20 degrees. All right, good. So with this, I'm going to use the law of sines to figure out cosine beta. The reason being is because I know that cosine 20 degrees over 1 is going to be equal to cosine beta over 2. Again, cross multiply divide. So we'll have 2 times cosine of 20 degrees. So we go to cosine beta. Take the inverse on both sides of this part in particular. You'll have beta is equal to, let's see, second cosine, I think it was 2 times cosine of, is it 20 degrees? Yes. 20 degrees. There is an error. So let's go ahead and do this separately real quick. There probably is an error. And the reason being is that you see how that value is bigger than 1? It's probably going to be an error, which actually makes your life pretty simple. Yeah. If there's an error, that means that this one has no solutions. There's no solutions to this one. You know what? The only thing I think we've missed on doing in some of the other ones is the part 2, which is to find the actual area of the triangle. I think I might have done that with 7. Yes. I did not do that with 8. I think, and I skipped over 9. Okay. So let's go ahead and actually find the area of this triangle. Now, on the other one, on this problem right here, we can't find the area because this one has no solution. So you can't even find the area of the triangle on this one, okay? So you don't have to worry about that. So let's go ahead and actually now do this one, and let's find the area of this triangle. Let's do part 2 of this one. Again, once you get to the stage, just use this formula. I just wanted to point it out to you. Actually, what I'm just going to do is go ahead and just point it out to you. You could go ahead and use any formula you want on the sheet, but you have all the sides, so you should be able to figure this formula out for part 2. Now let's go ahead and move on to question 9. Question 9 actually has us do the same thing. Let's form the triangle. This is side angle again. So again, you have to check for second triangle. Check for second triangle. Automatically, you got to do this when you got side angle. So let's go ahead and first draw our triangle. Fill in our parts, capital A, B, lowercase b, capital B, lowercase b, uppercase C, lowercase c, alpha, beta, gamma. Now let's go ahead and actually fill in our parts that we do know. You know, A is 3, B is 1, and beta is 110 degrees. Okay, so I'm going to use the law of sines, specifically with sine of 110 degrees over 1. And I'm going to make that, I'm going to look for sine of alpha over 3. So when I can do cross multiply divide, I will have 3 sine of 110 degrees is equal to sine alpha. I take the inverse of both sides, so I can go ahead and find out what alpha really is. So for that, let's go ahead and bring on my calculator, move it out of the way, and take sine of 3 times the sine of 110 degrees. Error again. We're probably going to go ahead and have another no solutions with this one as well. And the reason being is that we're getting small sides and big angles. So that's most likely the case. 3 sine of 110 degrees. Yeah, that number is bigger than 1. Just make sure we did our math right. Double check the answer. But yeah, this one has no solution as well. No solution. Okay. Great. Now, this one has no solution. You don't need to find the area for this one. Let me double check this one real quick. Make sure I place everything in the correct spots. Just because I want to make sure that before we leave this problem, everything was done right. And I think we went ahead. Oh. No, there it is. There's the problem. There is a problem with this. Okay, so this one, it just seemed a little odd for us to get 2 no solutions. You would think that they're going to want you to practice. Yes, I did make a mistake. Why? Right over here, when I did this problem, there is no such thing as the law. There is a law of cosines, but not in this fashion. Not in this way right here. Remember, this is, and let me tell you where the mistakes happen. Right there, right there. That's exactly where the mistakes occurred. So which means that this is all invalid right there. What really should have been placed, the sine of 20 degrees is equal to the sine of beta. So when we do the math in this part, when we go ahead and do 2 times cross multiply and divide 20 degrees is equal to sine of beta. Then we have to take the sine inverse of this. So it's cancel, and we'll get the sine inverse on this side. Now this one might actually achieve us a beta. Let's see what it is. And let's take a look at it. So I'm going to put that second sine of 2 times sine of 20 degrees. Yeah, 43.16. So this one, it does have a solution. 43.2. Let's just go ahead and round that. 43.2 degrees. Now, that's one of your betas. Now, since this is 43.2 degrees, that means that one of the triangles, let's see, let's do 180 minus 20 minus 43.2, 116.8. 116.8. Okay, so this could be a possible triangle. Well, actually, this is a definite triangle right here. But we have to check for the second triangle. And the reason being is because we're using the law of sines, we may have a second triangle. Now, what do? First of all, to see if there's a possible second beta, okay, we're going to go ahead and take 43.2, okay, and find out what it is, this beta second over here. And we do that, well, actually, not necessarily there. Beta second is actually this angle right there. That's what beta second is. Okay, so the way we find that out is we do 180 minus 43.2. So let's do that. 180 minus 43.2 is 136.8. So possible second triangle is 136.8. Now, let's see if this is reasonable. Remember how we were given, first of all, alpha of 20 degrees? So if I do 136.8 plus 20 degrees, I get 156.8, which means that it's possible. Actually, there will be two triangles. Okay, so we have one triangle. So what does that mean for us? That means that this alpha, this A, it still is not unknown. There's going to be two answers to that, and also two different sides for beta and alpha. So what do we do here? Okay, we're going to use this angle. We're going to form the same triangle on top. A, lowercase a, B, lowercase b, C, lowercase c, alpha, beta, gamma. And we're going to put in some things that are the same. Okay, this is 20 degrees. What changes? That this new beta might be 136.8. So if that's 136.8 degrees as a possibility, that means that we really have this other angle that might be alpha. That might be 180 minus 156.8. 156.8 came from, here if you want, let me do it slower for y'all. It came from 136.8 minus, also minus 20. It was me adding those two together and subtracting them, but so that's 23.2. So that means that you might have another one, which is 23.2. What's going to happen is that this one, the beta and the alpha are different, and the A is going to be different in itself. So the only thing left to do, well, actually, because remember B and C, I think we've been given that already, which is 2 and 1. So this is 2, this is 1. So what we're going to do, we just have to figure out this last A for the second triangle. So for this one, we're going to do sine of 20 degrees still over 1 is equal to the sine of 23.2 over A. So when you cross multiply and divide, A is going to be equal to, remember, cross multiply and divide with the unknown. So sine of 23.2 divided by sine of 20 degrees. You'll find an A. So let's see what that is. Let's see. So for one of my triangles, my A could be, let's see, sine of 23.2 divided by sine of 20. One of my A's might be 1.1518. 1.1518. 1.51518. Could be one of my A's. Now, that's the last measurement that we need here, 1.518. It actually seems reasonable. Let's go ahead and look to see if we have another reasonable solution here, what this A may be. Now with this one, we'll use the same thing. Oh, let me do it up here. Except that we're going to do the sine of 20 degrees over 1 is going to be equal to the sine of 116.8 over A. So this A is going to be distinct. And in this one, we're going to go ahead and do the same thing, cross multiply, divide. So I'm going to have 116. I'm going to figure out what the sine of 116.8 divided by the sine of 20 degrees. Let's see what that is. So for this one, we go ahead and do the sine of 116. 116.8 divided by sine of 20 degrees. And this A is 2.6097. 2.6097. 2.6097. So here's my two A's. And here's my two triangles with my two solutions. Now, what's the last thing you got to do with both of these? Apply the area formulas to this one. Remember, you still need to do step B, part 2. Area, which you should, I've written the formula a few times. We have to find the area of the triangle. Use one of the formulas for this one, and then you're going to get a second area for this one here too. So apply area formula. Okay, great. All right, well, thank you for watching this video. If you have any questions, please come see me before or after school.